Okay, it is time for the ever popular, very, very useful Chapter 3.3 in your books. This is Cpctc. I know how excited you are. First, let's start with what it stands for. It stands for corresponding parts of congruent triangles are congruent. It means just what it says. It means that only the matching angles and the sides of the respective triangles are congruent. Okay, so it doesn't mean that everything's congruent to everything. It means that there are specific pairs that are congruent to each other. But you guys are so smart, you already knew that, right? So let's see how circles factor into this, because we're going to start bringing some circles in. It's still mainly going to be triangles, but there is something important that you're going to learn from this. So let's look at this. Point O is in the center of the circle shown. By definition, every point of the circle is the same distance from the center. The center, however, is not, I repeat, is not a part of the circle. I don't know why it says and part. A part of the circle. Only the rim is. In other words, the actual circle itself. Okay, so we would call this figure circle O, or you're going to see it frequently referred to as that. Okay, that's the symbol for circle. So this right here means circle. Okay, it's got to have a dot in the middle. All right, so let's say points A, B, and C lie on circle P. PA is called a radius. Also, PB and PC are also called, each called a radius. Together, okay, the plural of radius is radii. Okay, which brings us to theorem 19. All radii of a circle are congruent. So all radii of the same circle or congruent circles are congruent. Keep that in mind. All right, so let's try a proof and see if we can put some of this stuff together. So we need to prove that AB is congruent to CD. Okay, so obviously first we've got these two triangles here, and we're going to have to show they're congruent first. That's how Cpctc works. You have to show that two triangles are congruent before you can show that corresponding parts are congruent. So let's start with our given, circle P. That's our given. Okay, we can say that PA is congruent to PB is congruent to PC is congruent to PD all together because all radii of a circle are congruent. We can then say that angle CPD is congruent to angle APB. And that's because vertical angles are congruent. Now, because look at this. We have a side, an angle, and a side in each one. So now we can say that triangle CPD is congruent to triangle APB. Okay, notice how everything corresponds. And that's because of side angle side as shown in step 2, then 3, then back to 2. And finally, and this is how it's always going to work when you prove something with Cpctc. Your one step, this is going to be a triangle postulate. And then your last step will be Cpctc. Your last step's not always going to be Cpctc, but you're always going to have a triangle postulate followed by Cpctc unless you're trying to prove triangles congruent. So, final step, AB is congruent to CD because now that we've shown the triangles are congruent, their corresponding parts are congruent. Okay? Yay, we did our proof in 5 steps. It's awesome. All right. This one I would like you to try on your own. Write down on paper or in Notability or whatever it is you're taking notes on, and bring it into class with you. I will be checking it randomly. All right, that's it. Nice, short, and sweet video for you all for the night. Cpctc, while a very used concept, is fairly easy to explain. Just remember, triangle first, then Cpctc. You cannot use Cpctc to prove triangles are congruent, just their parts. And that's only after you've proven the triangle is congruent. I can't stress that enough because that is the most common mistake made. Don't make it, or I will come to your house and I will ask you why. All right, have a good one, guys. You enjoy yourselves.